Hey all, this is Math 116, Section 0.6, Factoring. And factoring is a skill that's definitely going to come up in this class. As we go through this, I'm going to mention other videos I have where you can see a bunch more examples. This is just kind of an overview and assuming it's a review, but if there's a style you don't know, you can refer to one of the Math 94 videos where I do a bunch more of examples. So this first one is an example of just a greatest common factor. So greatest common factor is something that divides into all the terms. When I have numbers, what I do is I look at the least interesting number, which is probably 15. So 15 is just 3 times 5. So either 3 or 5 would have to be my GCF, and in this case 3 would go into everything. So I can take a 3 out front. For x's I have x squared, x, and x squared, so I can pull the lowest power always, so x. And then same thing with the y, I can pull out a y. So 3 into 81 would leave 27. I'm taking one x out of two x's, that's leaving an x, and then the y came out. 3 into 27 makes 9, and the xy came out, so you can see if I distribute back, I get this. 3 times 5 would make the 15, and taking one each out on the x and the y. So it leaves an x and y behind. Number 2. This is a 4-term problem, and greatest common factor in 4-term, which is going to be grouping, is covered in 094, section 5.1, if you want to see more of either of these two problems. So when we have 4 terms, remember that's the kind where we cover up the second 2 terms and take out the greatest common factor. So in this case, I could pull a y out of both terms. And it leaves behind the x and the plus 2. And then I need to get the same x plus 2. And if I take a 3 out of here, that will happen. And with 4 terms, that's the only way we have to factor them. And so these are always going to end up matching. That becomes your greatest common factor and comes out front and leaves behind a y plus 3. Again, section 5.1 if you want to see another like 10 of those or something. Maybe only 6. For number 3, this one, we're going to hope it has a GCF, and if you bust out the calculator and go 3 into 135, you'll find it goes 45 times. So I could take a 3 out front, and my smallest power is x squared, and that's going to leave an x squared from that first term. 3 into 42 would be 7 times 2, 14, x, and then 3 into 135 goes 45. So of all the versions of factoring, this is the kind that you really need to know because these are definitely going to show up. Some of the other ones you can kind of get around, but this is not one that you can get around. And this is section 5.2 in 094. So if you need to go back and look at a few more of these, make sure that you do check those out. So for this kind, we do what multiplies to be 45 and adds to be 14. And remember, we just set up our parentheses and then multiplies to the end, adds to the middle. So they both can be pluses since everything's positive. And it'll be a 5 and a 9 because it multiplies to 45, adds to 14. And again, the reason it needs to do that is because if we do our FOIL back, we get our x squared. And then we do a 9 plus a 5, that's our 14 on the inside and outside. And the last term makes that 45. And again, this is definitely a skill we're going to use going forward. So get that one down. Even if you're not super strong on the rest, that one's totally important. This one, number 4, is this is section 094. And you can go to my YouTube and just search 094, section 5.4 is where this one is. And what this is the factoring formula, a squared plus 2ab plus b squared. And if I factor this every single time, it's going to come out to a plus b quantity squared. And then there's another one that looks just like it, except this is a minus, and then that makes that a minus. So if we see the squares on the end, like the 64 and the 9, it makes me think it's going to be one of this style. And then I go, okay, what times what makes 64x squared? So that would be 8x. And then what times what makes 9? There's a plus in there, and that would be 3. And then to check and see if this is really what I think it is, I always pretend like it's going to work, and then I check myself and make sure it does. 2ab, so 2ab would be 2 times 8x times 3. So I'm just going 2 times this, and that gets me 6 times 8. There's our 48, x that we're supposed to have in the middle. So that's that kind. Again, section 5.4, if you want to take a look at some more of those. And this next one is also section 5.4, so 094, 5.4. So for this one, it's the a squared minus b squared. That makes a plus b, a minus b. And so this is just going to go 9x plus z, and then 9x minus z. The next one looks like one of those, except that x is not a perfect square. So that's actually the too easy it's hard GCF of x would come out front. 25x minus 1, because x times minus 1 gets me minus x. So that one was just a GCF from 5.1, but often gets confused with 5.4 difference of squares. And again, that's an 094 number. This one is not that great. So this is the kind no one likes. 3 times negative 12 would be negative 36. So we go our a times c, and we get this number on the end. This is section 5.3, and lots of people have a hard time with these. I don't think we'll do a ton of them this quarter, but here it is. So 3 times negative 12, negative 36. And then we do what multiplies to be negative 36 and adds to be 16. And so that would be, and if you can't see the number easily, what it would be, you can make a list. So it could be one's positive, one's negative. So it'd be 1 times 36, 2 times 18, and then right there you see if we make the negative on the 2, negative 2 times 18 makes negative 36, negative 2 plus 18 makes 16. So we do multiply the ends together and then do what multiplies to that and adds to the middle. And then this is called magic method. You may have a different method for doing this, which is totally fine. This is just the one I prefer. So what I do is I set up kind of a fake 3 here, and I'm just going to put in that minus 2 and the plus 18, and then I just divide the 3 right back out. And so that will be 3x minus 2, and then 3 goes into 3x, 3 goes into 18, 6 times. Again, I don't think we'll do a ton of those this quarter, but they could come up. So that is kind of the hardest version of factoring. Okay, so number 8. This one's a little bit trickier because 12 times negative 25 is a really big number. So sometimes when I have that, I'll just do 12 times 25. And that it's negative means I'm going to be looking for the difference between the numbers, so the difference is going to be 5. And then what I do is I factor this down a little bit, and then I kind of look at the factors and see if I can find 2 that are 5 apart. So here, hi Ellie, my cat's talking to me. So here we have 3 times 5 is 15, and on the outside we'd have a 4 times 5 is 20. So if I make the 15 negative and the 12 or the 20 positive, that makes the negative 5 in the middle. So again, sometimes the factors, it's easier to see it in the factors than it is making a big giant number. So just another way to get there. So this, we'd have a 12 up front. I'll put in the minus 15, and then that extra 12 and the plus 20. And then we want to think of it as kind of like a GCF. What's the biggest thing that divides into both 12 and 15? That would be 3. What's the biggest thing that divides into 12 and 20? That would be 4. And 3 times 4 is that extra 12, and that should always work. So 3 into 12 gives 4x minus 5, and then 3x, and then plus 5. Okay, and these next 6 are the ones I would have you guys try. And so right off the bat, we have the kind of unpleasant kind. And I forgot to say it back when I was doing the last one, but the way we can tell this apart is it's got 3 terms. It leads with something that isn't 1 and isn't perfect squares on the ends. So if it's perfect squares on the ends, it's probably going to be that a minus b squared. If it leads with a 1, it's great. We just do multiplies to the end, adds to the middle. But if it fails both those things, then we're stuck with the 11 times 5 kind of magic method. So 11 times 5 is 55, multiplies to 55, adds to 56, would be a negative 1 and a negative 55. And then again, I just do my 11x and kind of my extra 11 and throw in the 1 and the 55. And somewhere that extra 11 is going to divide out nicely, which is on the second factor for me. Wouldn't matter which order I wrote these in. And we get that. So if I wrote them in the other order, I'd still multiply, so it's still the exact same thing. Number 10, like I alluded to earlier, this one has squares on the ends, so it makes me think that 36x squared is the a squared in the formula, so plane a would be 6x, so I'm just taking a square root basically, minus, so it makes minus. B squared appears to be 49, so b would be 7. And again, my check is just to go 2 times 6x times 7. And the negative's covered, so that's why I started to write it and changed my mind. That'd be 42 doubled would be 84x, which is what our middle term's supposed to be. This next one, this is, well, has a common factor, so we should get that out of the way. I think we can get a 2 out of both. So 2x, and we always want to look for common factors first. So 2x and then 4x squared, and 2 goes into 98, that'd be 7 times, 49 times. Just jumping the next step in my head. And then 49 and 4 are both perfect squares, and that's that 2-term kind, so it'll be a plus b, a minus b. So 2x plus 7, 2x minus 7. And then this one is 4 terms. And so that's going to go where we cover up 2 of them and see what we can take out. So it looks like we have a's in common. So we'll go a and then b plus 8x. I know I'm going to get another b plus 8x. So for me, I like to just write it down. And then that kind of helps me see I need to factor out a negative 10. And you can check yourself by distributing. So negative 10 times b, negative 10 times negative 8 makes that negative 80. And then that's our GCF, so it comes out front. Though you could totally write it the other direction, it'd be fine. And a minus 10 left behind. And then just one more time with the sections in case someone was watching that and wanted to know where to look back to. This was 5.3, this is 5.4, this is 5.4, and this one was 5.1, all in Math 94. So 13, let's see, definitely a GCF going on. So 4, 12, and 20. 4 goes into 12 and 20, so that's going to work. My smallest power in x is x squared, and my smallest power in y is y to the first. So 4 into 20 would be 5 times. I took out 2 x's, so I have 2 left. I took out 1 y, so I have 2 left. 4 goes into 12 3 times. 2x is out, so it leaves 1 y out, so that leaves 1. And then here, these are the exact same things, so I need a placeholder 1 right there. Because when I distribute this back, I need to get this whole chunk back with a negative sign. And then this doesn't go any further. I know that because if I tried doing it the magic method way, 5 times negative 1 would be negative 5. There's nothing that multiplies negative 5 and adds to be 3. So that means this doesn't factor. Number 14, another GCF, so I'll come down here with it. 9 goes into everything, as does x squared. So that's going to leave behind x squared plus x, and then minus 54. And if you're ever unsure what's leaving behind, just distribute back. So there's our x to the 4th, 9, 1, 2, 3, x cubed. And then, oops, see, that's why you should distribute back. So if you do something silly like that, you catch it. That should be a 6 right there. So then we got 9x squared. This is 3 terms leads with a 1, so it's kind of the nice kind. Again, this is the one that you probably need to be good at. And this is section 5.2. This was section 5.1. We're looking for 2 numbers to multiply to be 6, negative 6, and add to be 1. So plus 3 and minus 2.